Okay, so in the last session we discussed about different methods present in collection interface, and that we have tested through list and array list, and we have seen how to iterate the elements present in a list. So again, we have different classes under collection. We just seen only list and array list. Now we'll see the other classes. So the other classes that we'll see, first we'll start with the linked list. Okay. So actually, if you see in the previous example, we were always saying like this. Right? Okay, because what we are doing, because array list is subclass of list, we are creating a array list object and we are passing that object to the list reference. I mean, in real world, what we'll do, I mean, generally we will not, we will assign the objects to the interface, and from that we will call the methods. Most of the scenarios we will not directly create the objects for the classes. Not only for the classes, but if you take for example, if Spring is there, okay. So in Spring, most of the scenarios we will not create directly object like this. I mean, anything like this. So basically we will have some interfaces which will have some methods, and there will be some implementation classes which will give the functionality for the methods present in the interface. If we want to call those methods, we'll not create the objects for those classes. So what we will do, say for example, list object. I'm just giving an example, but okay. So when I say like this, I mean somewhere in the configuration file, right? So somewhere in the configuration file, we will have that configuration. That I mean not for the array list, but for the most of the classes. I mean, these are the predefined classes. Assume that if we have our own classes and interfaces. So, this is not the right syntax, but not like this, but something like this we will define in some configuration files. So, and wherever you want, you will just call the interface, and from that interface you'll call the methods. And auto where means at the starting of the application itself, it will look for the corresponding classes. It will create the object. So actually internally it is doing the same. For example, if I do like this, internally what it is doing, internally it is doing this. But what it is doing, it is taking care of creation of the object and destruction of the object. So we no need to take care of the life cycle of the object. So that is the reason. I mean, most of the examples I have given like this, but you can directly, instead of array list, you can do like this. Okay. So in the array list, actually we have seen only, I think we have seen only one type of object creation, right? So there are different ways. So here I did not pass any constructor. You can pass some different constructor, like for example I have this so what I'm doing here, I am passing the size of the array list. Suppose for example, if it is array, what we need to do, we need to mention the size of an array while creating, right? Whereas for array list, while creating array list object, we are not giving the any size, because by default it will assign with some value. So if you don't want the default value, you can give your own value. You can give like 10, 20, anything. You can give your own value. So the default, it'll have some default value, and if you want, we can write our own value. So now what will happen? For example, so this means what? So this means this array list will allow 3 values, but as soon as for example, so because array list can take any type, even if I give int or if I give string or if I give any other object, it will take a different type of objects, right? So now I have added three integers, and here I have given size as 3. So now what will happen if I try to, if it is array, suppose if it is array and if we give the size as 5 or 3, as soon as we reach as 3, and if you add another element, then during runtime it will show like array index out of bounds, right? Here I have given 3, and as soon as it reaches 3, I'll add another one, 4. It will not give any compile time, and it will not give any runtime, because internally what is happening, as soon as it reaches 3, there is some formula. Based on the formula, like it will calculate something like based on current value into 3 by 4 something. So it will calculate the size, and it will increase the array list size. So assume that current size is 3. As soon as it reaches 3, based on the formula, it will say like 10 or something. Not exactly 10, but based on the formula. So, and again, if it reaches to 10, again it will take the same formula. At that time, current value is 10, so it will current value into 3 by 4 something. So it will keep on increase the, automatically it will keep on increase the size as soon as it reaches the maximum limit. Okay. And the same way we have so here this is default constructor. This I have passed some size, and again you can pass some collection. Okay, so actually it is like this. So if you see here, we have this default constructor collection. So collection means any collection class. Okay, any collection class. So now my linked list is also a collection class, right? So I can pass that collection class. So then what is the use of this? So the objects that are passing to this collection is different from the array list, because I mean every class is having its own features. So when you're taking that class and adding the objects, means there will be some purpose for each class, and that is the reason that you're choosing that class and you are adding the objects to the class. And so when you add the list of objects to any collection class, and when you pass that collection class object to the array list constructor, what will happen? Those objects will be that collection will convert to the equivalent collection of array list. Okay, so I mean not only array list. For example, if I have a vector, to the vector, I have added some elements. Say, for example, so now actually this is a list collection. Sorry, this is a vector collection. Now what I can do, I can pass the vector collection to the array list. Now what will happen internally? This vector collection will convert to the equivalent collection of array list. So the whole thing, the whole thing will become like this. Okay, I mean, so this is not required, just for your understanding I have written here. Actually the whole thing will be converted like this. Okay. Next we'll see about linked list. Okay. So then first we'll see, I mean, the example is same, and the methods are also same, like whatever you have in array list, you're having the same methods in linked list, but it has some extra methods. Let's see what are those methods. First we'll add some objects. I'll add employee object. So if you observe here, I have added two objects, but those two objects are same. Okay, because I have added same object twice. Now if I see the size, okay, if I see the size, it is 2. uh, I'm just iterating. Okay, so I have added same object twice, and it is showing those two objects two times. So it is accepting duplicate objects like array list, and if I add null value, so it is accepting null, and if I add another null, okay, so null also it is accepting more than one time. Let me add some. Okay, so I have added four objects. Now you see different methods from there. So add is same, and we have already seen this. So no, add index object means now I want to add a new object at second position. Okay, so I'll give second. Okay, I'll add this for each after that. So I have added this at the second position. These are all the same like we have seen in the other example. Add all, add first. It will add the object at the first place. Last means it will add the object at the last place. Contains all. Reach, get first, get last. Index is empty, iterator. So these are the extra methods that we have here. So an offer first, offer last, peak, peak first, poll, pop, push. Okay. So these are the extra methods that we have in the linked list. Let's see that. Offer. So it is returning the boolean value. Let's say I'm offering this employee object. So let me add some break here. So we have initially we have these objects, and after calling this offer, what happened? It is adding that object at the end of the list. So basically, it is adding an object at the end of the list. When we call offer method and passing that object, it is adding that at the end of the list. So offer first means it is adding at the starting of the list. Okay, it is adding at the starting. Obviously, offer last means the name itself is there. It will add at the end of the. Okay, it is adding at the end. So basically, if you just call offer, then it is adding the object at the at the end of the list. Otherwise, we have separate methods for adding it first and last. Okay, now if you see the other methods, peak. I mean, these are the same related to the offer. Say, for example, let me print this. Okay. So what happened? We have uh, we have all these objects in the list, and when I call peak, it return the first object from the list. So okay. So when I call peak method, it is returning the first object from the list. Now if I call other methods, peak first, obviously it is returning first, peak last, it is returning at the last. And the poll, so poll, if you see here what happened, it returned the first object, and if you see here, before calling the poll method the size is 5, and after calling the poll method the size is 4. So what it did, it took the object from the list, it returned that, and it is deleting that returned object. So it will return the object from the list, and after returning the object it will remove the object from the list. Okay, so that is what the poll is doing. Same thing, poll first means it will return the object from the first place, I will remove it. Poll last means it will remove object at the last position, and it will remove that. Push means it is like adding an object. It's the same like adding an object. So for example, if I add an object, okay, so it is just adding an object here. Okay, so that's it. Other methods we have already seen, like iterator. So iterator is same, like the way that we are doing, we have seen another example. You just get the iterator, and it is returning the iterator object, and the same thing for list iterator. So the difference between the linked list and array list. So internally what is happening, for example, if I have 10 elements, okay, Assume that I have these many number of elements. Okay. So this is 0th index. So actually, assume that I have these many number of elements in the array list. So now I want to insert some value here. Okay, I want to insert some value here. So initially there is no, I mean everything is full. Now I want to insert at the middle of the list. So in array list, what it will do, internally what is happening, it will it will it will shift each position one at a time. Okay, so what it is doing, first it will check the uh, position. So I want to insert at 7th place. Okay, so it will shift the places. So it will check, suppose it will check for the index. Okay, this is not the 7th position, it will go next, so suppose this is the 7th position. So the rest of the elements, what it will do, it will shift it has to shift. So earlier in the 7th place, assume that I have value 10 at the 7th position. Now if I insert some value, and okay, so assume that this is the first list. Now I want to insert some value at the 7th position. Now assume that this is the new value. So what it is doing, before inserting this value here, it will shift all the values. Earlier at this position, this is the 7th position, some value is there. Now because I have added one value at the 7th position, it will shift all the other values to the next place. So that means what is happening, if you are inserting at some place in a array list, it will take some extra time to identify the position and shifting the existing position values to the next position. So that is where it will take time. So basically the insertion and same thing for remove. For example, I want to remove some value here at the seventh position. So what it will do, in a previous case, when I'm adding a new element, so it will shift to the next position. So if I remove element at the seventh place, it will shift the elements to the uh, it will increase the it will decrease the position one, and it will shift it will decrease the each position value by one, and accordingly it will shift all the elements. So when in case of remove and insertion at at a specific position, ArrayList will take some time to shift the values. If it is a retrieve operation, it will work fast. Suppose I want to get some value at 10th position or 14th position. Since it is managing the indexes and it is preserving the order that you are inserting. So if you want to go for retrieve operation, it will work fast. Whereas if you want to remove or add a element at specific position, then it will take some extra time. Okay. So whereas when you come to the linked list, what will happen? Linked list, let me say this. Okay, so linked list, what is happening? It'll have like this. Suppose this is the first element. Since this is the first element, it doesn't have any previous element address, so this is empty. So value, next value address. So this is the next value. So this is the next value. This is one value. So this is one value. So for example, employee object is there. Employee object 2. Employee object 3. Employee object 4. So previous value address save. So address, it will have some hash code. Some assume that address 1. address 1. So if you see here, I have the first object here, and that object X is having extra two things. One is the next object address and the previous object address. Since this is the first object in the list, it doesn't have any previous object address. So this object is having the address of next element. So because next element address is address 1, so it is having address 1. So the second object, it is having the value of the previous object and the address of the next one. So basically what is happening, every object, it will have the address of the next and previous element addresses. So while inserting, suppose if I want to insert here at this place, so what it will do, since we know what is at that position, what is the object is there, and for that object what is the previous object, what is the next object, so we know the addresses of the objects present at that position, so it is easy to insert or remove objects. I mean, it's not easy, but the computation process will be quick because it knows the address of the objects at that position. It is not shifting like in array list. What it is doing, it is shifting. If you remove or add objects, it is shifting the other objects position by one. Whereas in linked list, it will just it will just add the object by identifying the next and the previous object's address. So the array list is suitable when you have more number of retrieve operations, and linked list is better when you do frequent remove or insert operations. Okay. Mostly linked list you will use in the scenarios, in the queue related scenarios, you will use linked list. Okay. Okay. Next we'll see vector. Okay, I mean the procedure is same for all these different classes except to know uh, the different new methods available in that class. Okay, so the vector, it is also same, like it is accepting duplicate objects, and we have we are iterating through for each, and the extra methods that it is having is iterator. I mean, for iterating, we have iterator. We have seen so far iterator, list iterator, but there is another third one, that is enumerator. Okay, we will see how to use that. So there is a method called elements. So if you call that method, which is returning enumeration. So on the actually on the vector, you can call all the three. Actually, we have three classes where you can iterate the list of objects. One is iterator, which is returning the iterator. Another one is list iterator, which is returning the list iterator. The third one is elements, which is returning the enumeration. So, iterator, list iterator, we have already seen that. The enumeration, so if you remember the previous example on iterator or list iterator, we have two methods. One is while iterating, we have two methods. One is has more. I mean has next and next value. So here also a similar kind of methods in the vector, while iterating elements through enumeration. So that is has more elements, and next element. Okay, so it is the same thing, but the actually the thing is here, the enumeration you can use only on the we have some legacy classes in the sense of these were introduced in uh, initial version of Java, and after that they fine tune some of the internal concepts. But the vector, we have another class called stack table properties. So we have some of the legacy classes. So the enumeration, if you want to iterate objects through enumeration, that is possible only on the legacy classes, not on any other classes. Okay, so this is only for the enumeration you can do only on the legacy classes. And the similar way, like we have seen the different constructor for array list, linked list is also having the same type of constructors. And when it comes to the vector is almost same, but just one extra. So this means it's a default constructor, and this means what we are doing here, we are giving the initial capacity as we are giving initial capacity as 2, and this means the initial capacity is 2, and the next thing is as soon as it reaches 2, increase the capacity to another 4. Okay, increase vector size. So this means, for example, I'm adding some numbers. Okay, 54. So my initial capacity is 2. So now as soon as it reaches 2, now let me print the size. Okay, total size of the, I think we have that method to check the capacity. Let's see that. Yes, we have this capacity method. So initial capacity is 2. I have added 2 elements. Now we'll see what is the updated capacity. So initially is 10, and after also 10. So we just added 2. Now let me add another one. Okay, still it is 10. Okay, maybe we need to add up to 10. Maybe until unless it is finishing that, it is completing those 10. it looks like it is not increasing. Let's do that. So now I have 1 2 3 4 5 6 7 8 9. Exactly added 10. Let's see now. Okay, still okay. Think we are checking the capacity for the wrong one. Okay. Or let's remove this again. So we have added 2 and 4. Now I'll just add 3. So if you see here, the initial capacity is 2 and as soon as I added third element, the capacity got increased. How much it is increased? So what I'm saying, as soon as it reaches the limit, increase the limit by 4. So initially 2 by 4 means 6. So whereas in array list, there is nothing like we can specify the increasing capacity. For example, the array list size is 1000 initial size, and it reaches that limit. And if you want to add a next element, so based on the formula, current capacity something into 3 by 2 something. So assume that the updated capacity is 1500, but you are just adding only one element. So those other rest of the blocks will be empty. Whereas here, what we are saying, just increase the capacity every time it reaches the limit. So vector is having the provision to increase the capacity to our desired number of positions. I think it doesn't have, we have the same methods, whatever we have in, except this capacity and the elements. Yes, that's it. Okay, there is nothing much difference other than this knowing about this capacity. The next one is stack. So first let me run this. Okay, and same way like how I am adding the list different objects to the vector or array list or linked list. Here also same way for adding. If you see the other methods, so these are the methods that we have, extra methods that we have in the stack, that is peek, pop, and push. So, so pop, if I say, so we have seen this. So what it is doing? It is it is returning the last element from the stack and it will remove it. For example, let me print the size. There is I mean, so okay, so if you observe what is happening, actually I have written this while loop, but I did not call, I just commented this next element method. So what is happening? Since this will always be, when I say next element, then only it will it will go to the next object. It will traverse to the next object. So since I commented, it is just always this is always true because it is there in the first position itself. I am not calling the next element. It is going forever. That is why if I say here, it is not stopping. If you see here, it is continuously running. Okay, you will if you want to see that if I give any print statement here, See here, it is continuously going forever. Okay, so you should be very careful when you are writing your programs, because I did not call the next element. So when I call the next element only, it will go to the next element. Otherwise, it will always be there in the first element, and this is true forever, and it will go in the infinite loop. Okay. Okay. So it is not coming here actually. It is it is keep on executing that while loop. It is not coming here. So the pop method, what it is doing, it is returning the last element from the object, and it'll remove that object from the stack. Push means obviously it'll insert a element to a stack. Peek means it'll it'll return element, but it will not remove. Let's see that. Say for example, so before and after it, the size is same. So it is returning the last element, but it will not remove that element. Whereas pop, it will remove the object, it will return the object, and at the same time it will remove that object. The other methods are same. Mostly this stack, I mean, we are not using, but internally these concepts like vector stacks, for some of the JVM functionalities, internally it is using this stack behavior, but we'll not regularly use these concepts, but just for our understanding we are checking. So the next one is set. Similar way, like the list, linked list, how those classes are implementing list. In a similar way, for set also, there are multiple classes which are implementing set, like a hash set. Okay, sorted set is an interface, but it is implementing that. Navigable set also we have seen, and tree set. Okay, so we'll see the hash set. Same way, like for list object, how we are giving array list of right. So similar set object also we'll give first we'll check with hash, right? Okay. The similar way you can pass it to set, or you can directly keep it like hash set. Okay, so now this is the same thing like for adding an object, we have this add method. Now, when compared with the list, there are slight differences with the set. We'll see that now. For example, I have added employee object, same object twice. Okay. Now, let me call statements. Okay, if you see here, I have added employee object two times, the same object. It did not return any error while compiling and while running, but it just took only one object. Okay, so basically the hash set, I mean set related classes, it will not allow duplicate objects. I mean, even if you can add it, but it will not take it. Okay, the same thing for null. Okay, if I have given null two times, what happened? Actually, if you see here, I have added four objects, two employee objects and two times null. But what happened? The total size is 2. So if you pass duplicate objects, it will just take only one time. And if you pass null more than one time, it will just take only one time. Okay. So if you see here, this one, what I did, I have added first I have added employee object, and after that null, again employee object, after that null, and employee with id 2, employee with id 3. But if you see the order where it is printing, it is printing in a different order. First null came, and after that employee ID with the second number, employee ID, after that employee ID with the first number. But actually I have added this first at the first time. But if you see the order, it's in a different order. So basically the set related, not all the classes, but the hash set will not preserve the order of insertion. Whereas if you see the list related classes, it is preserving the order. That means whatever the order that you inserted, while when you print also, it will give in the same order. Whereas the hash set, it will not maintain that order. But the other difference is list related classes, it will allow duplicate objects, and it will allow null value more than one time. Whereas here, if you give duplicate objects or null value multiple times, it will just take only one time. Okay. So if you see here hash code, right, we don't have this there. So if I print the hash code, okay, for each item, what I'll do, I'll print the hash code. Yeah, because for null it will not have any object, so it is throwing that error. Let me remove that null. Okay. So the hash code is this one, like this. So actually this hashing related, like hash set, tree set, or hash set, hash map, hash table. So all these classes, when you add any class, any object, each object will be assigned with a unique hash code. So while even when you insert it, when you insert multiple objects to the hash related classes, what it will do, while storing, it will store the elements based on the hash code value. It will not store the elements based on the order that you are inserting. It'll store based on the hash code of that object. So each object will have a unique hash code, and based on that it'll maintain the order, but it will not maintain the order based on the insertion. Okay. So yeah, that's it. So related to the hash rate, so the only difference that we identify is it will not maintain the order of insertion, and it will not allow duplicate objects. Okay. Whereas this one, the sorted set is there, right? So it will maintain the it will sort the elements. Suppose if you don't give any special sorting, for example, tree set is there. For example, I'm just adding some numbers. Okay. So if you see here, actually, I have inserted 1, 10, 4. But what happened? It is by default it is sorted. Okay, so it is showing in the ascending order 1, 4, 10. For example, instead of numbers, okay, I am giving some strings. So now if you see the order, how it is printing, I did not say anything, right? I did not say like, okay, so Avi has come first, and after Ram, after that Zoo. I did not say that, but it is sorting. So if you are not specifying any or customized comparison, custom sorting, then what it will do, if it is a number, then by default it will sort the numbers and it will show in ascending order. If it is a string, it will sort the strings based on the alphabetic, based on the alphabets. So for strings, it will sort based on the alphabets. For numbers, it will sort based on the numbers, and it will show in the ascending order. But this sorting order is not there in the hash set, but that is there in the sorted set. Actually, hash set is directly implementing the set interface, and sorted set is also a child interface for the set, and the tree set is the class which is implementing the sorted set. Okay. The hash set, I think, yeah, that's it. There are no extra methods there. So we have this comparator because we just discussed, right? If you don't specify any our custom comparison, by default, the sorted set will sort the result based on the number or based on the alphabets. But if you want to have your own custom sorting, then we will use the comparator. We'll see that example. But other than that, yeah, other than that, we don't have any separate methods. So in our next session, we'll see an example for comparator, and we'll see some other collection classes and interfaces. So in the today's class, what we did, we have seen some collection classes like linked list, vector stack, hash set, and we have seen different constructors. Okay, so one last point about the hash set, that is, we have seen here, right? What is that? Different constructors for array list, linked list, vector. The same way, we have the constructor for hash set, but the main point here is, so we have seen the default size, right? So again, so each collection class, when you don't specify, obviously it will have some default, it will assign with some default size. So now we have seen how to specify our custom size, custom capacity when it reaches to that limit, right? So for example, so one is fine, like the collection. So if you pass any collection object, then those that will convert into, suppose now I am passing list here, so the list will convert into the equivalent to hash set. Okay, the list of objects will convert into the equivalent set of hash set of objects. I mean, this is a common constructor in all the classes. The other one is Suppose if I give the initial capacity as 4 and the next one is, suppose if I give 0.9. So 0.9. So what is this 0.9 F? So this is called fill ratio, okay? So fill ratio means in the previous example, if we have that, yes. In the previous example, in the vector case, as soon as it reaches its limit, what happened? The total capacity increased to 6. But when it got increased, when you try to add the third object, capacity is 2. When you try to add the third element, the total capacity increased to 6. Whereas here, the initial capacity is 4. This 0.9 means as soon as it reaches to 90% of the total size, right? Whereas here there is no percentage. As soon as, I mean, this is by default, this is 100 percentage, right? So as soon as it reaches to, and when you are adding next element, that means the total capacity filled, that means 100%. And when you add the after reaches to the 100%, when you try to add the next element, then it is increasing the capacity. Whereas here, when it reaches to, when I say 0.9, when it reaches to 90%, that means when I add 3 elements, then it will increase the capacity, right? It's like that. 0.9 means that filling ratio. So if I say 0.7, that means as soon as it reaches to 70%, then it will increase the capacity, then it will increase the size. But the default value, if you don't mention it here, if you don't mention anything, suppose in this one, the default fill ratio is 0.75. This is the default. Um, F means since it is a floating point, and if you just give it like this, then it will not accept. So that is the reason I have given floating F. So that is the fill ratio here when it comes to the hash set. I mean just like instead of waiting for till it reaches its maximum limit, when it reaches to some percentage, then it is increasing the capacity. Okay. So yeah, that's about different ways that we are creating objects for list, array list, linked list, vector, stack, and set. And we have seen different methods. I mean, mostly if you observe, what is the extra difference that we have seen in these classes when we compared with the array list example, this pop, peak, offset, that's it, right? And the hash set is not accepting duplicate objects. And there are slight differences But other than that, the way that you are creating object, the way that you are iterating the objects, everything is same with slight differences. That is the reason, if you understand the first example that we have seen, how we are iterating the objects, how we are adding, removing. If you just got that point, then the rest of the collection classes, it is the same behavior. Okay. Yeah. So in the next session, we'll see the some other collection classes and interfaces.
Okay, sir.
Okay.
Okay, sir.
Thank you.
Thank you, sir.
Bye.
Thank you.